Hi, everyone. I'm Sandy Lucas, the Program Manager for the Climate Variability and Predictability Program at NOAA. It's 4 o'clock now, so I think we're going to go ahead and start this webinar series so that we give ample time for our presenters and give ample time for presentation questions. So, as I said, I'm Sandy Lucas, the Program Manager for the Climate Variability and Predictability Program at NOAA. Thank you for joining us for this webinar series called Years of Maritime Continent and PISTON Field Campaign. This is a continuation of a series of webinars for the CVP program that started several years ago. Today's webinars are being recorded and will be available from the CPO website under the Climate Variability and Predictability section. If you've missed any of the prior talks in past CVP webinars, I encourage you to go to the website and view them at your leisure. I'd like to start today with a bit of background on the importance of these YMC and PISTON projects. In July of 2013, the first plan for the Year of Maritime Continent was discussed in Davos, Switzerland, and then it was introduced at the Pan-Clivar Pan-GWEX meetings in The Hague, Netherlands. The goal of the Years of Maritime Continent is to expedite the progress of improving understanding and prediction of local, multi-scale variability of the maritime continent weather climate system and its global impact through observations and modeling exercises. This early plan was at that time, this early plan was the start of the development of an ongoing set of international field campaigns and modeling efforts led by the countries of Japan, Indonesia, and the US, in partnership with many other countries such as Malaysia, Australia, the United Kingdom, the Philippines, and China. Of particular interest of YMC to NOAA is that is to improve understanding of processes that affect the propagation of interseasonal oscillations, such as MJO, in the maritime continent and its broader regions. And MJO is important to local weather and climate, as well as having global teleconnections. However, the maritime continent region can sometimes act as a barrier to the propagation of MJO, and weather and climate models have a hard time reproducing this effect. So in response to that need, the Climate Variability CVP program solicited observation and modeling projects that investigate different processes that affect the speed, intensity, disruption, and/or geographic placement of the MJO propagation in the maritime continent region. Additionally, in collaboration with the Office of Naval Research, CVP supported several activities of the PISTON Field Campaign. This year's webinar series covers the 16 projects that were funded by CVP. I look forward to hearing from the CVP researchers and the results in this webinar series. I would also like to thank Gabriela Jeliazkov, the CVP student visitor and the organizer of this series, for all of the hard work that she has done putting this together and coordinating this activity. At this point, I will turn it over to Gabriela for the full introduction of the series and the introduction of our speakers today. So Gabriela, whenever you're ready, go ahead.
Thank you, Sandy. Hello, everybody, and welcome to the first of 10 webinar sessions on the topic of Years of Maritime Continent, which will feature 2 presentations per session and will run from September 10th, 2020, which is today, to March 11th, 2021. This series of presentations will share the latest results from these projects and will allow the PIs to discuss the importance of their work, outcomes, and lessons learned with a broader scientific community. We hope you will enjoy today's talks and ask plenty of questions. As you listen to these presentations, if you have a question you would like to ask the presenter, please raise your hand. Raise your hand is a feature which you can find on the control panel for GoToWebinar. At the end of this presentation, I will unmute those who have raised their hands so that they can ask their questions using their audio. If you have audio problems, I will ask you to type your question into the questions box, which can also be found on your control panel. Our first speaker today is Chidong Zhang from the NOAA Pacific Marine Environmental Laboratory. He is the lead of the Ocean Climate Research Division. His research interests include weather-climate interface, tropical intraseasonal variability, and in situ observations using autonomous devices. Chidong is also the co-chair of the YMC Science Steering Committee. Chidong, thank you so much for joining us, and at this time we will turn the controls over to you.
Thank you, Gabriela. Thank you, everyone, to join this seminar. First of all, I'd like to thank Gabriela and Sandy for organizing this webinar, and I pretty much look forward to hear everybody's presentation. Now I'm shifting to my presentation. Can you see my presentation now?
Yes, we can.
Okay. So in my presentation, I will give you a very brief update of the recent progress of YMC. I hope everybody on this webinar is familiar with YMC science, so I won't spend too much time on that. So these two cartoons show give you some ideas of the breadth of YMC science. On the left, you see the symbols illustrate different scales of phenomena over the maritime continent. We have MJO propagating eastward across the maritime continent. And then we have monsoon that symbolized by these two big arrows pointing north and south for both summer and the winter monsoons. And we have a cold surge from north. We have a Borneo vortex. And then we have a lot of aerosols in this area. Of course, one of the most important phenomena in this area is the Indonesian through flow, represented by these blue arrows. And on the right is a cartoon demonstrating the local variability associated with the diurnal cycle. During the daytime, the convection is mostly over land, is isolated and tall. At the night, the convection move over water and become a mesoscale system. And associated with the diurnal cycle are land breezes and sea breezes. All those wind will influence surface fluxes and influence ocean process. In addition to air-sea interaction, we have some ocean process independent from the atmosphere, such as the internal waves. I'm pretty sure we'll hear a lot the talks during this webinar and touch upon all these different phenomena and different processes. The global importance of the maritime continent mainly comes from its barrier effect to the MJO. And this schematic diagram illustrates the global impact of the MJO. I won't go into details. Just to point out that the remote effect of the MJO depends on the longitudinal location of its convection center when it's moved eastward, and the barrier effect can limit the eastward extension of the MJO convection center, and therefore will modify the MJO global impact. So in the rest of this talk, I'm going to cover 4 areas: field campaigns, data, publication, and the conferences. This is a list of currently planned or executed field campaigns, and it does not mean for you to read all the details. I just want to point out that almost 2/3 of the planned field campaign has been complete. That's above this green line. And those numbers, we're going to see that again, mark different field campaigns. And I have to emphasize that those field campaigns are truly international activities, and they are organized and participated by many different countries. The rest of the field campaigns that are coming, some of them are planned for this year, but have to be postponed because the COVID-19 pandemic. And we're pretty much look forward to complete those field campaigns in 2021 or 2022. So as I mentioned, those numbers here on the map on your left corresponding to each different field campaign. I just want to highlight one, number 6, and that is a boreal summer monsoon experiment conducted by Jamstack, and which is going on, which is happening as we speak. It will it started about 2 weeks ago and will complete Monday next week. So this is the only one field campaign that is not postponed by the COVID-19 pandemic. And we have to congratulate the Japanese colleagues for their effort. So I'll move to YMC data. And there are two categories of YMC data. One is from field observations, field campaigns. There's a lot of data, and here I'm only list data that's already available for public use. GEMSTAC has conducted the field observations before the YMC start. They call the YMC pilot study in 2015, and then 2018 and 2017 and 18 they repeated their field campaign. And those field campaigns are near the west coast of Sumatra, and they involve a lot of instruments. And you can go to GEMSTAC YMC website, and you can see many of the data are posted for public use. And there's equatorial line observations. Part of this already completed. Part of them have been stopped because of the pandemic. The one that has been completed are the Seagull LiDAR observations, and their data has been posted for public use. And there has been an ocean mixing experiment conducted by Japan, Indonesia, Australia, and China, and they measure the ocean profiles in the Indonesian seas, and some of those profile data are available for public use. And meanwhile, the Australian colleagues is using their investigator research ship and did 2 field campaigns in the Eastern Indian Ocean and the Timor Sea. And some of their ocean profiles and radar data are available for public use. And the second category is the data from the regional operational network. And they have several kinds of data. The first is radio sound data. You can get the unQC, unqualified, quality controlled radio sound data. But I have to emphasize that I will show you a map later. The radio sound instrument sensors are used in these areas are very different. So to calibrate them to get a standard data quality control is very difficult. But GEMSTAC has done that and make unified QC data available from 2017 to 2019. And the second category is land surface stationary, land surface synoptic station data. These hourly observations of surface variables, including SST, humidity, pressure, and wind. And this is mainly from Indonesia, from 2018 to 2019. The third one is the rain gauge data, also from Indonesia. There are about 84 rain gauge stations, and they have hourly rain gauge data from 2017 to 2019. The data quality control of these 2 surface data are almost done, and one is completed. It will be released for public use. And the radar data, the Darwin radar data has been processed, and it's multiple year data already released for public use. And Courtney Shoemaker has been working on radar data from one station at Pandang, and I'll defer to her talk to about the details of this data. And as part of the YMC data set, we have a very high resolution microwave based rainfall estimate. That's 30 minutes time resolution and 8 kilometer spatial resolution is available from 2003 to present. And Ping Xie will talk about this in his talk. All right, so this just tells you the distribution of soundings network in that region, and you see different color represent different type of sensors, and to get a consistent data quality is a big effort, and GEMSTAC has achieved that. The second one is to give you an idea about the surface station observations from Indonesia. There are 32 of them. And the third one is the rain gauge data, 84 rain gauge data from Indonesia, and that's what I mentioned. And this is radar network, and it's a daunting task to get all those radar available and data quality controlled, and so they can be used. And so far, we have a limited manpower and funding, so we only focus on 1 or 2 stations. And hopefully, in the future, we would have a capability to get all those data ready for application, for research application. This is the ocean buoy networks, and some of them are from the past. Some of them are planned, and there's have a rich set of data that we plan to collect and make it public available. All right, let's move to the next topic, the publications. As many of you probably already know that we organized a cross-organization special collection, and the co-organization means the special collection covers 7 professional organizations such as AMS, AGU, AOGS, EGU, and so on and so forth. And they all agree to join this special collection. And some of them already put out the special call, and some of them have not. You just have to mention to the editor that handle your manuscript, and they will inform us when your paper is accepted by those journals. And this is a interesting experiment in scientific publication. As far as I know, there has not been such a cross-organization special collection. Now we'll see how it goes. So far, we have collected 95 published articles, and you see all those on the left are the journals, and the numbers in the parentheses are the number of articles published in that journal in this special collection. The best benefit of this cross-organization special collection is you don't have the reader. As a reader, you don't have to go to each journals or even each organization webpage to select YMC publications. You can just go to the Jamstack YMC website and click the special collection, and you have all the publication in this collection list. We call this master list. And so it's a one-stop shopping. You can find all the YMC publication here. All right, conference. As you know, we had 4 international workshops plus a kickoff meeting at Jakarta. And the 5th international workshop was planned this year in Taipei, and that has to be postponed because of the pandemic. And our colleagues in Taiwan plans to continue this effort to make sure once the pandemic is over, we will convene in Taipei for the 5th international workshop. In addition to that, there has been many special meetings and sessions related to YMC. I counted the 36. I may miss something, and including the special sessions in AMS, AGU, and AOGS annual meetings. So there are some issues we have to face, and number one is we have to continue our data archive, and there is still a lot of data out there, and we have not been able to archive because of the data quality control issues or some other issues. And after we do that, as the YMC data policy states, we will release those data for public use. And an issue is whether we want to build a user interface that would make the application of the observation of data easier, such as what we did for Dynamo. We will continue doing capacity building, and this will go beyond the training workshop and go through collaborative research and publication. And I want to emphasize on this. Once the data are released, especially the data from the local operational network, I encourage everybody who wants to use the data to reach out to the regional scientists and include them in your efforts to use those data for research and publication. That's a great effort to for capacity building, and that would make our research in the future easier. And observation modeling integration has always been a challenge, and the modelers love to run model observations, love to collect data, and how to put them together. That would be a continual effort, and I encourage people from both sides reach to each other and try to make sure our data are used by model and the model run are validated by observations, not only by the reanalysis. That's what I want to emphasize. Field project, as I said, we still have several field projects need to be completed, and we still face some challenge in addition to the pandemic. There are some logistic issues and some funding issues and so on and so forth. And the last one, not the least, is the question how we continue YMC research. That depends on research funding, and we have to still try to work with the funding agencies to convince them the importance of YMC studies, and trying to figure out how the YMC studies will continue to be supported by funding agencies. That's all I want to say, and I welcome questions.
Thank you so much, Chidong. If anyone has any questions, please raise your hand using the control panel option, and I will unmute you. I'm going to go ahead and unmute Mike Patterson.
Hi, Chidong. Nice overview presentation. Regarding the observation modeling integration, can you speak a little more about the models that are involved in the effort, operational or research models in the U.S. as well as internationally?
Yes, you know, in this webinar, we will hear several presentations about their modeling efforts, and I'm looking forward to that. Those are the models that specifically designed, not designed, specifically applied to the YMC problem. Operational, you know, models, they are global. They don't tailor their model to the Maritime Continent. What I want to emphasize on this observation model integration is to encourage the modelers to not rely on reanalysis to validate their model, but somehow take the pain and take in situ observations to compare their model, because the experience says that in some areas in this Maritime Continent, probably reanalysis product may not be the most reliable data set that you want to validate your model. I give you diurnal cycle as example. The new ERA5, which has a diurnal resolution, but if you compare that with the in situ observations, you will find they have a tremendous bias. So just be careful using the reanalysis in this complicated region to validate your model.
Thank you.
I'm going to go ahead and unmute Carol Ann Clayson for the next question. You may need to unmute yourself on the other end as well.
Okay, I think I'm unmuted both ways. Is that correct?
Yeah, we can hear you.
Okay, great. Hi, Chidong. I had a child wander in, and I'm wondering, did I miss a slide that was showing where all the radiosondes were located? I caught it right. You had a radar and the buoys, and
This
yep,
is radio.
basically like this. Okay. And does that include? So it looks like are all of those on islands, or did you have a lot of ship-based radiosonde networks?
You're right. The ship-based radiosonde works are categorized as the field data. So this is the operational data. So yeah, we do have. Yeah.
Okay, great. And from what I have seen, based on looking through, as many archives as I can be getting my hands on sounding data, that the YMC sounding data is going to mean this area of the oceanic marine boundary layer is better sampled than pretty much anywhere else on the globe in terms of sheer numbers of radiosondes. So that will be fantastic. That will be a resource, I think, that is going to be highly valuable to many researchers over the years.
Right. Yeah. Thank you for your comment, but I need to caution you that only the radio sound data from small island probably can represent marine boundary layer. The radio sound data, even on the coast of large island, probably the boundary layer transition from open water to land, especially with the complicated terrain, we do not know how that transition take place. So if you want to use those radio sound data to represent marine boundary layer, marine atmosphere boundary layer, I would say probably you only want to find the radio sound data from small island.
Yes, thank you. And I should have been clear. That's why I was asking about the research vessels and the small islands. But you make a very good point, because I think a lot of people also think that when they see all of this, that even somewhat larger sized islands can still represent the marine boundary layer. And I'd say that's probably more of a hope than an actualities. So thank you for emphasizing that point.
Great, it looks like we have time for one more question. I'm going to go ahead and unmute Pallav Ray.
All right, I think you mentioned about a one-stop place to get all the papers, but is there a one-stop place to get all the land-based observation?
Yeah, that's our plan. All the data archived and released for public use will be available from the Jamstack YMC website. Yes, that's our plan.
But is there anything already there?
Yes, you can go there. Not the land-based data from the operational network yet. I mentioned the sounding data is there. I correct myself. Sounding data should be there. The surface synoptic station data and the rain gauge data are not there yet. I hope it will soon be there. They're going through the final quality control now.
All right. So I mean, is there a possibility that you guys will send an email through the YMC email group when it is released?
Oh yeah, we always do. Yeah, but let me see. Yes, we can do that. Yeah, when the big chunk of data is available, we can send we can send the emails to the community. Yes.
Thank you.
Thank you so much for everybody's questions, and thank you again, Chidong. Looks like we're going to be moving on to the next presenter. Up next is a presentation by Jim Moum from Oregon State University. Jim Moum is a physical oceanographer with a background in engineering and physics. His research interests focus on turbulence and mixing processes, the hierarchy of high Reynolds number geophysical fluid dynamics that create instabilities leading to turbulence, and finding ways to measure those. Jim, thank you so much for joining us. And at this time, we will turn the controls over to you.
Okay. So PISTON was planned to take place within the YMC timeline and region. It was planned initially as a land, air, sea experiment. PISTON stands for Propagation of Intraseasonal Tropical Oscillations. And the focus was on the Boreal Summer Interseasonal Oscillation, the BSISO, and with a particular focus on the diurnal warm layer and how that interacts with land. It was initially planned to occur on the west coast of Luzon, and we had a number of hiccups in the planning, including lack of permission to go and work in the exclusive economic zone of the Philippines. So this is an example of a carefully planned experiment, complete with a extensive science plan that was led by Eric Maloney that had to be re-engineered on the fly. We ended up staging out of Taiwan and didn't know where we were going to go while we were still in port. And it turned out to be a tremendously successful experiment looking at the effect on the atmosphere and ocean of tropical cyclones. I should say too that ONR really wants to do a land, air, sea experiment. The ONR contribution to Dynamo began as a land, air, sea experiment, ended up as an important contribution to Dynamo by extending the duration of the research vessel Ravel as a point in the dynamo array with expanded set of measurements, but was 700 kilometers south of Colombo, the nearest land. This experiment ended up about 1,000 kilometers from land. So there's the front page of the science plan for PISTON. I think it's like 100 pages, a 47-page science plan. That's right. It was coordinated with our colleagues in the Philippines from both the atmospheric side and the ocean side, and included sounding and radar sites on Luzon and coordination with Philippine research vessels. And it was planned to occur at the same time as the NASA CAMPEX campaign, which was an aircraft-based campaign looking at aerosols and a range of other things in the South China Sea and off the west coast of the Philippines. In 2018, CAMPEX was canceled due to aircraft readiness. We were ready to go, and it was too late to cancel. So we went in 2018, and we ended up going again in 2019 when CAMPEX did fly. In planning for 2018 experiment, our marine scientific research request to the Philippine government, which is required under the UN Conventional Law of the Sea to work within a country's exclusive economic zone, was denied roughly a week before we went to sea. So following the 2018 experiment, we planned for a 2019 experiment, which would coincide with the CAMPEX NASA flight experiment, and we filed a new marine scientific research request, which was again denied. And this was done at a level much beyond our pay grades. And I would like to thank the people in the State Department who really tried hard to make this work, and also to our Filipino scientific colleagues who really tried hard to make this work as well. And we really didn't expect those denials. In 2018, we operated out of Taiwan and ended up about 1,000 kilometers to the east of the Philippines, working within a box, and we deployed oceanographic moorings that were really the most heavily instrumented oceanographic moorings we've ever deployed, complete with a high density of turbulence sensors for the first time. And as we operated within this region, multiple tropical cyclones passed through, and part of the experiment was an exercise in TC avoidance. We had daily detailed weather briefings prepared by a forecast team led by Michael Bell at Colorado State University, and that helped tremendously in just local at-sea planning. Here's the details of the track here. There's extensive measurements around both mooring sites. One is down around 13 north, one is around 16 north along 135 east. In the vicinity was the research vessel Mirai. We did some joint dual Doppler exercises with the Mirai while at sea. And there are a number of Korean and Japanese moorings in the vicinity that we haven't yet looked at very carefully. If you look to the right, I need to get rid of this thing. If you look to the right, you can see at the top the named typhoons as they went by our site. There's the wind stress, the solar radiation for the time period that we were out there, which was about 2 months, in the form of 2 different legs with a stretch for rest and refurbishment in Palau as Super Typhoon Mangkhut went through. And there's Super Typhoon Mangkhut, and this is an important story. There's a list of measurements that were made here. These are also, I think, almost totally archived now at a NASA site, and that site is on my last slide. So there an extensive suite of measurements that were roughly repeated in 2019 in collaboration with the CAMPEX campaign. However, here's the site we occupied in 2018. In 2019, again, we had planned to go off the west coast of Luzon, ended up off the east coast of Luzon, outside of the Philippines EEZ, but within aircraft range of Clark Air Force Base, so that the aircraft could fly over the vessel and we could do joint operations. So the ship maintained positions within the aircraft range. There is the ship track out of Chidong on the north end of Taiwan this time. The extensive track is associated with typhoon avoidance. We had planned to stay in this vicinity for the entire duration, but again, we had to get out of the way of typhoons during the experiment and ended up over here for some period of time. And again, these are the regions of the main sets of measurements. There's Typhoon Lingling and Typhoon Tepa that we had to avoid while we were at sea, and the sets of measurements are shown here, including the aircraft, the Learjet and the P3 that flew over the ship on a number of occasions. Those data, a lot of those data are fairly new and are still being worked out. Elizabeth Thompson from NOAA Earth System Research Lab in Boulder made this slide up that shows the measurements made from the Thompson in 2018 that shows remote sensing both upwards with radar and LiDAR and downwards using Doppler sonar or acoustics, as well as in situ measurements made from various platforms, including really detailed, very near surface measurements from a surface following platform of temperature, salinity, currents, and turbulence for the first time. And there are two 2020 papers on the physics of diurnal warm layers that have come out of that so far, and there are two more papers on the way. I won't belabor that. This is, in 2018, we went out on the Thompson. In 2019, we went out on the Sally Ride with the configuration in a very similar manner. One feature is the radome from the Seapole radar run by Steve Rutledge out of CSU, which is required some discussion with the ship's complement in order to allow it to obstruct the view from the bridge. This shows the ship coming out of Chidong Harbor, picture taken from a drone run by our colleagues at National Taiwan University, who, by the way, are probably the most hospitable people to host an international science party that I've ever met. So we did 8 per day balloons, similar sets of measurements. The end result is that this was a continuously profiling set of measurements from 600 meters beneath the sea surface to 27 kilometers above the sea surface from the balloon's perspective, and looking out laterally 120 kilometers using the sea pole to get rain rate information. And that provides a nice perspective of the experiment in this movie made by Kyle Chudler working with Wei-Shin Xu and Steve Rutledge at CSU. And this shows a map of the region during the 2018 experiment. And what we're going to see is we can see rain rates from the IMERG satellite product and 10-meter winds and isobars at the surface. And over here, this circle denotes the ship. And within the ship, we can see the rain rate estimates, the detailed rain rate estimates from the Seapole radar. At the bottom, we can see a timeline of total precipitable water, SST, and CAPE. So we can follow this in time as we watch this ship and the rain rate within the ship and the other products as the typhoons go by or the tropical cyclones go by. Most of these reach typhoon status. So the ship is coming down now, and we can see this sequence of TCs go by. And you can see the distinction between the local rainfall and the satellite estimates of rain rates. Here we're off doing dual Doppler exercises with the JAMSTEC ship research vessel Mirai, and eventually heading back. And as we head back to 135 east, which is this dotted line here, we can see a typhoon spinning up, Typhoon Jebi. Typhoon Jebi entrains with it. Somehow there's a long tail that extends out to the equatorial Indian Ocean of intense winds that entrains itself with the tropical cyclone. So this strong wind event actually disrupted our plans. This is the strongest wind event we've seen. There's some interaction there between the typhoon and monsoon winds extending out way into the deep into the Indian Ocean. And this passes, and as we're preparing to make land in Palau for refurbishments, we were informed, we had predictions that showed a super typhoon forming to our east. And in preparation for that, we put out a set of profiling floats in the upper ocean as super typhoon Mangkhut came by. There we are, we're sitting in Palau here on the ship. Mangkhut's going by us, and right over the set of profiling floats that we had deployed ahead of it. And Mangkhut goes on and actually caused a fair amount of damage on Luzon. And we went back to sea. And one of the consequences of this is measurements from 2 profiling floats, and these profiling floats are set to profile in the upper 200 meters. Those 8 profiling floats were deployed to get 20,000 or 150 meters, 20,000 profiles over a 2-month period, including the passage of multiple typhoons. And you can see the effect on the upper ocean as the typhoons pass by. You can see the tremendous cooling associated with super typhoon Mangkhut, followed by Trami, followed by Kongray, and eventually U2. Mangkhut was right over top of the floats. Trami was off a little bit. Kongray was further away. There is a paper that was published in 2020 that shows the effect on the upper ocean and the potential deceleration or weakening of Typhoon U2 as it approached the cooled water, the water that had been cooled by the transit of the previous super typhoons. So one big story from this experiment is the response of both the atmosphere and the ocean to the tropical cyclones as they came by. And if we look here in zonal winds at the top, zonal currents below, you can see in the zonal winds, you can see the passage of these strong wind events. And this is Kongray here, this final one. And what we can see, if we look down in the ocean, in the currents, you can see these bands of propagating. You can see bands of phase out, phased bands of velocity. You can see it better in shear, but I'm showing velocity here because it compares best with zonal winds. This shows the phasing of the inertial gravity wave propagation into the thermocline from the upper ocean caused by the excitation due to the winds from the tropical cyclones. If you look up, you can see the same thing in the atmosphere. You can see the upward propagation into the stratosphere of the near inertial waves. So even though the tropical cyclones have passed through, there's a long-lasting local effect in the atmosphere, up in the stratosphere, as those waves propagate up in the atmosphere. We know in the ocean that the shear associated with these inertial gravity waves has a big effect on mixing in the thermocline because they're associated with high shear, reduced Richardson number, and therefore instability leading to turbulence. I expect the same thing happens in the stratosphere. And the fact that the storm has gone by maybe doesn't matter to the troposphere, but it does to the stratosphere locally. If we look at the entire time series in the upper 400 meters of the ocean, this shows shear. This is the early part of the experiment before Super Typhoon Mangkhut and its followers. This is the after part of the experiment. And what you can see between the early part and the later part is more intense colors. Those more intense colors are banded in phase space so that you can see the propagation downwards of the near inertial gravity wave field. The enhancement of the shear is about 1.4 between the before and the after part, between 100 and 300 meters that's in the thermocline below the mix layer. In terms of the turbulence excitation is a factor of 17 in that same region. So the association of the inertial gravity waves and the mixing is tremendous in the ocean, and I'm sure it is in the stratosphere. We also put out these two amazing moorings that had these highly instrumented with temperature, conductivity, velocity, and turbulence sensors. All told, there are about 200 sensors on each mooring, something we've never done before, or roughly 100 sensors per mooring, there we go, including an array of turbulence sensors. Really great data recovery. And what we can see in terms of meridional flow and the meridional near inertial flow, you can see the pulsing of the near inertial gravity wave field associated with the pulsing in the atmosphere associated with the passage of storms in the atmosphere above. We're still working on a lot of these data, especially the turbulence data, but so far the results they're new and exciting. I guess that's what I can say. So to make a few summary points, PISTON was a land air sea experiment, and like Dynamo, it ended up being an air sea experiment. The planning was for BSISO forcing, and both 2018 and 2019 campaigns were really dominated by easterly waves and tropical cyclone activity. We were blessed with improved technology and sampling frequency compared to precursor experiments that were similar in nature and included some of us in all of them, including Toga, Core, and Dynamo. We made tremendous advances in measuring the upper few meters of the ocean, and one of the outcomes of that has been a new understanding of the physics of the diurnal warm layer. CPOL is a tremendous upgrade over the Toga radar, and included in these measurements were the University of Wisconsin high spectral resolution LiDAR. The long-term moored records offer a new perspective of the total ocean water column. So the new data set extends from 600 meters beneath to 25 kilometers above the sea surface in a sparsely sampled part of the world, the Western Pacific. These data are now being used to test gridded reanalysis products, which are in turn used to understand mechanisms controlling convection in the region. The heavily instrumented moorings from PISTON provide a low latitude analog to a nearly identical high latitude mooring south of Iceland, which was funded by another ONR project at 60 North. So this provides a high latitude and a low latitude analog with a very similar set of measurements put out by the same set of PIs. And we're hoping to really gain some new insight into that part of the fluid dynamics phenomenon. Here's a list of the PISTON science team, including several PIs who are funded primarily by the NOAA CVP program, and some of whom will give talks as part of this seminar series. The PISTON website is shown here, and the data are, I think they're still password protected, but that's where they exist. And at some point, they'll be made public. I think it's 2 years is the ONR requirement. So that's all I have to say, other than to say thank you to Sandy and Gabriella for organizing this talk and inviting me.
Thank you so much, Jim. At this time, again, anyone who has a question can raise their hand, and I'll go ahead and unmute you.
Well, someone should at least challenge my statement that the propagation of near inertial gravity waves into the stratosphere are significant to atmospheric dynamics.
I'm going to go ahead and unmute Tim Lee.
Hello, Jim. I just have a question. Seems your major objective is try to understand the BCs, Boreal Summer Intraseasonal Oscillation. You show a lot of the tropical cyclone impact. Did you actually see anything related to the intraseasonal oscillation?
As far as we can tell, it was relatively weak while we were there. And one problem with trying to resolve the BSISO with a short time scale field experiment is that it's hard to measure a whole cycle because the cycle's long. So you kind of have to be lucky and you have to be out there for a long period of time. We were kind of a long ways east of where the signal is the strongest. So I'm not sure that anybody has really followed up on that quite yet.
Thank you.
If anyone else has a question, feel free to raise your hand. You can also use the chat box if that is something you're more comfortable with. I'm going to go ahead and unmute Eric Maloney.
Can you hear me?
Yeah, we hear you, Eric.
Yeah. I'm not going to challenge your contention about the importance of the waves in the stratosphere, Jim. I think they probably are important for forcing the mean, zonal flow and stuff like that. So I'm all with you on that. I guess I had just a slight comment in response to Tim Lee. We've been doing some analysis of the large scale state during PISTON 2018, and we have a paper in review on that right now led by Adam Sobel. But I agree with Jim that there wasn't much in terms of BSISO activity, but if you were reaching for straws, I guess you could argue that there was a suppressed phase of the MJO that occurred right at the very end of PISTON 2018 that caused a suppression of convection over the domain, but that's pretty much all we saw.
Yeah, thanks, Eric. Eric would be more of an expert on that aspect than me.
I believe Chidong Zhang has a question as well. Feel free to unmute yourself.
Hey, Jim, you mentioned that you have more advanced observing technology since Dynamo to resolve the very fine resolution, upper ocean stratification to really resolve the diurnal warm layer. Have you got any results to share about the new knowledge you learned from this new technology?
Oh, yeah. So there are two papers in JPO in 2020. Ken Hughes is the first author of that paper, of both those papers. What we can see is the details of the velocity structure for the first time, and we can see the details of the instability. So one thing I think we've learned is that you can see the way that the heat is transported through the diurnal warm layer and where the handoff is between insolation, incoming solar radiation that's attenuated as a function of depth, and the turbulence. So we have a better handle on what the turbulent heat transport is. And we think we can identify the instability. It's rather than a Kelvin-Helmholtz instability, it's an asymmetric HOMO instability that's the cause of the that triggers the mixing, and the distinction is important for predictive purposes. So we haven't got to the point of trying to develop a new parameterization yet. What we're trying to do is understand the physics so that we can get to that point.
Thanks.
Thank you so much. It looks like that's all the questions we have. We would like to thank you again for joining us for this set of presentations in our series on Years of Maritime Continent. I would like to thank today's presenters for taking the time to share their work with us. The recording of today's webinar will be available within the next week on our website, which is cpo.noaa.gov/CVP. We hope you will join us for the next webinar on September 24th. Thank you so much.
Thank you. Bye.
Yeah, thank you, everyone.